With the world increasing the demand for electricity each year, the 125-year-old technology of a one-way connection of generation, transmission, and distribution is getting old. In fact, the global electricity demand is expected to rise up to 75% by 2030, which would make it even harder for the grid. In the initiative of smart grids into the system, there would be a two-way connection between that of the sections, which allows technologies to be able to aid the grid. In the installation of the smart grids in areas such as Toronto, Canada, and Texas, USA, electricity prices will soon fluctuate over a course of a day. To be able to take advantage of this, home energy management systems are introduced. In relation to the smart grid system, home energy management system integrated houses play a vital role in the intelligent handling of electricity and real-time demand. Smart houses with its home energy management systems help enhance the overall reliability, efficiency, economics, and energy conservation of the distribution systems. According to a research made by Hartano et al., the benefit of HEMS to the smart grid system improves the voltage profile and power losses, and the study also showed that voltage fluctuations caused by large disturbances can be lowered by up to 5 times. Nowadays, HEMS have gained popularity because of their advancement, convenience, and affordability. Anytime soon, the large-scale usage of HEMS will help change the way of electricity usage in every household. Home energy management systems is a technology developed to seamlessly connect both hardware and software that allows the user to monitor energy usage and manually and/or automatically control appliances under one system. It allows a specific user to control the flow and utilize power in the transmission or distribution system that has been in use in the energy sector for a long time. Home energy management systems, which was created and developed recently for residential customers, have emerged. For the components of home energy management systems, first is the smart appliance. Smart appliances are the appliances that are usually used in homes such as washing machines, refrigerators, room heaters, etc. They are integrated with intelligences and enable them to communicate with a centralized system, which makes them different from other normal appliances. Next is the sensing devices. Sensing devices detect parameters such as voltage, current, light, and temperature. After the smart sensor detects these various parameters, they send signals to the centralized system to monitor, control, and optimize schedules for smart appliances that are used at home. Next is the measuring device. Since HEMS enables the user to control and manage parameters, it is necessary first to measure it, which makes the measuring device a vital part of the HEMS. Inside a smart home, the centralized system together with the metering devices collects and delivers information and signals, which helps optimize the electricity consumption and production schedule. Next is the UI or user interface. A user interface is a device wherein the user can interact with the centralized system and acquire information regarding their consumption, analysis reports, status of appliances, and dynamic pricing. The most common type of interface used in HEMS is the touchscreen interface. Lastly, we have software platform. A software platform is used to manage and optimize the consumption of the user. From the feedback it receives from the sensors and smart meters, it can perform functions such as decision-making, and it can also perform optimal load scheduling. In order to connect the different components such as sensors, smart meters, and HEMS, communication protocols such as Zigbee, Wi-Fi, and Bluetooth are used. The process can be simplified to its roots of being a feedback control system. To better understand the concepts, each phase will be explained together with the HEMS system being an example. Inputs are data points that are recorded by different sensors, which in this case are the temperature sensors, photo sensors, and other sensors. The inputs will then proceed to the controller. The controller is the mechanisms by which changes in the process are accomplished to influence the output variable. The HEMS systems contains a computer wherein it functions as a controller. It commands different appliances based upon the instruction. The plant or the process is the action done by the HEMS system. It can be either consuming at less demand times of the day and many others. Lastly, the feedback will be technically by the user or automated by the system. The system will gather new inputs and the previous outputs. The system will be automated. The classification of HEMS can be divided into two. It can be based on functionality or based on technology. For the functionality, it can either be information-based or control-based. Information-based are products that are only limited to providing information to the users, for example, viewing his energy consumption. On the other hand, control-based are products that integrate automation through programming and/or added technologies. These products not only show information to the user but also intelligently act as a feedback control system, such as providing necessary information and control required to reduce energy consumption. On the basis of technology, first is UI. For the UI, HEMS are classified based on their type and method to link with the user. They provide information in order to execute decisions and enable control of the systems and processes by the user. Next is smart hardware. Smart hardware are physical products which enable the control of various appliances to control energy demand. Example of this is smart plug, which has the ability to communicate and transmit data to the centralized system, the status of the energy consumption of the device connected to it. And lastly, the smart platform. This allows interaction between the various components on the integrated system and also with the user. Adapting HEMS can offer us a lot of benefits. One of these is information, where HEMS provides users with information such as weather, temperature, energy consumption, etc. Next is remote control. With HEMS, users are able to control the lighting, heating, ventilation, and other conditions of their house even if they are physically absent. Usually, remote control with HEMS can be done by the use of smartphones, laptops, or tables, which shows the interface to the user. For energy management, HEMS provides detailed information regarding the energy consumption trend in real time. With this insight, the consumer can instantly detect issues such as leak or surge in their energy consumption, and they can immediately take action and fix the issue. And lastly, efficiency improvement. HEMS can also provide and assess the performance of individual appliances regarding its efficiency and total energy use. This would be helpful to the user to determine if a specific appliance is to be replaced or to be modified to improve its efficiency. It also provides information relating to the malfunction of devices and power overload, which can help in terms of the safety of the user. Study about the efficiency of HEMS from Bowden and Reaper stated that HEMS could reduce the operation cost of electricity by 23.1% and decrease the residential peak load demand by 29.6%. Aside from the benefits, there are also challenges in adapting HEMS. First is the cost. This type of system often allows long-term savings, but many people are not willing to pay for the initial investment to install HEMS. Next is the security privacy risk. Since HEMS provides the ability to the user to monitor and control energy consumption, it creates a benefit, but at the same time a risk for the user if it falls into the wrong hands. Since some devices are able to connect to the internet, it introduces a new level of exposure to the security and privacy of the user. Lastly, awareness and knowledge about HEMS. According to the study by PG&E, 2015, 37% of the people they surveyed had no awareness that HEMS exist. While 27% were aware and 35% were aware but their idea was not specific. Out of the surveyed people, 38% adopted HEMS while 62% did not. And lastly, home energy management systems HEMS are beneficial technologies that aid the user to view, manage, and automate different technologies in the comforts of our own home. However, there are still a lot of challenges or problems to be solved in order to fully utilize this technology.